Was there any quiz for exception?
You're great.
No.
Okay, thank you.
You'll get it.
Cover unit testing or version control today, not going to be in your exam, okay? It's optional. Next week, final review. I'll try to review the whole semester in that one class. I'm going to see a lot of like summary in there, less of the detailed things that we will normally do because I will not have enough time to do all of that in one class. After that, final exam. And then on the day of the final exam, I think is when your project is due as well. So after that day, you will be done for this class for this semester. Okay? All right. Why am I covering unit testing and why am I covering version control? All of those are very important things once you go into the industry. It's less important when you're actually in school. I think version control may be important before you go into industry because people do look at your quote-unquote software engineer profile, right? So imagine that is where we go in and look at people's code, how do they write code, how do they document, what repository or code base they contributed to. That's what people like to click in and what people like to put in on their resume. So you kind of need that before you go into industry. But unit testing is definitely something that's super important outside of school. So you'd be like, oh, I remembered it from 3 years or 2 years ago. You probably will not use this after you transfer, after you do your grad school. But your professor, your TA, may secretly be using this to grade your program. Right? I'm not using it right now because this class I don't require you to compile. It is an intro to programming. When you go into more advanced programming classes, compile is like the most basic thing. If you code will not compile, it's like you get 0 credit, like no even partial credit, because they assume you have been programming for a while now, and when your code can compile, people can run unit tests against your code. So I'm going to show you what unit test is. So you kind of see, oh, my TA is unit testing my code. Also, after you graduate, it will also be easier for you to understand this concept because that's exactly what it asks you to do once you get into programming. The reason that is so popular in industry but not in school is because we use that to test large programs. Right? When you're writing a small piece of the things that's only 10 or 15 or even 20 files. It's relatively small. I mean, sure, you can test them. I will show you an example using your final project and how I would test it, but not that essential, right? So people don't normally teach it in school. However, when you go to a company, a tech company that have a software that works by hundreds or thousands of programmers, every time you add something in there, you're risking of breaking every other people's code. Right? Because everything is connected. Therefore, unit tests become important. It not just tests your code. Other people have the test run at the same time. When you contribute your portion of the code into this giant system, they want to make sure that you do not just break their code. Unit test is always running. Why do we have unit tests? Or what makes unit tests possible? Object-oriented programming is exactly the foundation of unit testing. Because people write object-oriented programming, everything's object, that's why you can test the object individually. So yeah, we know the benefit of object-oriented programming. Unit test is when we isolate a portion of the program independently with the rest and just test that. Allow you to focus on your code and your code only. Right? I'm going to test your code, assuming that other people's code are tested by their unit tests. Right? So when you put something in, you're going to add your own unit test, but at the same time, you will see thousands of unit tests running at the same time, right? You probably just wrote 5. So because all the other tests are going on as well, so that you don't break their code. What does unit test looks like? When you design a unit test, it first of all needs to be reusable and independent. It focuses on a small behavior of the big program, right? One single behavior, isolated from the rest of the unit test. You don't want to have your unit test depends on other people's unit tests, right? Have expected output. So your unit test is a test case, meaning that you need to tell your program what this should be. And then you can compare it with what it actually is. And then you know whether it's good or not. Also need to be really fast, right? If your program have unit tests run twice as long as it compile, then don't want to run unit tests anymore. Now, when I talk about unit tests, I know I talk about R and program. You have probably noticed that I have not mentioned C++ at all, because this is not a language-specific concept, right? Whatever language that you use, as long as you go in and write a big program, you're gonna have unit tests. And today I will show you C++ unit test as an example, because this is a C++ class. But no matter what language you use, whenever you contribute to a bigger system in a bigger team, then you need to have this mindset of testing your code and what is unit test and how to use it. The example template I'm going to use is Google Test. Google Test, it is an open source. When I say open source, remember when I talked about VS Code, why I like VS Code? All the plugins that other people wrote, that's all open source, right? Open source meaning that they release their source code so other people can all contribute to it to improve it from the big community of developers. So Google wrote their own unit test framework called Google Test. And they're like, okay, I'm going to open source it. It's not like tracing, right? We just open source it. So we released the code, they open sourced it, and ever since it became really popular. Google Test is very well designed. It allows us to simply set up scenario for a test. You will see it's very simple and straightforward. Specify expected output, right? Which is a requirement for unit testing. Once you just make your test, Google Test can take and run all of them automatically, give you very nice formatted output to tell you which passed, which failed, why. So very helpful. So that's what I'm going to use today to demonstrate what is a unit test, right? This is not the only unit test framework. Google Test does support all languages, but there's other test framework out there. It depends on the company that you join, or depends on the project that you work with. They may have their own places of different unit test framework. But they will be very similar. It's a framework that can read specific style of tests, run it, compare with expected output, give you a nice output formatted list and saying that whether it passed or not. Step by step. Let's look at Google Test. Google Test asks you to frame your task in a function. And then the function has to have the name test. So that's their format we follow for us to use the Google Test framework. So say this is my test case, then my test name is always test. But then in the parameter is where I have test case name and test name. I'm going to tell you more about why do we have two. Tests are grouped together into what we call test cases, right? Where each test is then written so that it focuses on a behavior of that case. So when you group, I'm going to show you, right? For each test case, you can say, I'm going to test this function. I'm going to test this class. I'm going to test this operator. That's a test case. You test a behavior of your program where the test name are a smaller portion that you use to group together. For example, when you test a function, you want to test this function whether it can take exception, whether this function return the right number, whether this function has correct if or else statement, right? There's many things you could test for one function. All those are tests that you group under this function test, right? So that's test case and testing. Now this is an example of a unit test, and this example I have the test case name operator greater than, right? That is saying that I am testing specifically the operator greater than overloading. That's my example. And my test name is greater, meaning that there's many things I could test about this greater than operator. This one specifically, I'm testing whether it can compare one thing that's greater than the other. Okay, that's all my test. I can have more. I'm going to show you in the next slide if I have more. And the way that you do it is that inside your test case, you create local variables. Very important. They have to be local because everything that's local preserve the independent of the test, right? If you're local, you're not like calling other tests. You're not like calling other part of the program. So it is isolated, and you're only testing your part. Now, if you look at this a little bit, let me zoom in. In my test case, I'm creating two local variables that I want to test with this operator overloading, right? So the overloaded operator should compare minion. Therefore, I created two minion locally, right? Where it has its name, it has its, I don't even remember what we have, like eyes or pears or bananas or something like that, right? You create those two, and then I'm gonna try to compare them. Now the expected results is in this GTEST assert statement, where this is saying GTEST is the class, right? That's what we're using. assert true, meaning that this statement should be true. If it's not true, then they fail, right? So right down here, when I want to test two different medians with some extreme cases, for example, it has 200 bananas, for example, would I break? This has 1 banana, would I break? Again, assert true, median 3 should be greater than median 4. Now let's look at our assert statement. Assert true and assert false are what you use to tell the expected value for conditions, right? Conditions always return true or false. There are other you can do. You can do assert equal. Very common where you have a calculation here, like a function here. That function should return 5, for example. Then that will be 5. I'm asserting equal that this function return 5, right? What else do we have? Oh, there's also a separate, and then yeah, let me talk about this first, right? Assert not equal, right? They're not supposed to be equal. Assert less than, assert less equal to, assert greater than, assert greater equal to. All of those what we call are fatal assertions. In the same one, you can also see there's non-fatal assertion where, yeah, sure, you failed, continue, right? And on the right is what it verifies, right? So the first thing is they're going to try to run this. It's going to try to run that. The corresponding operator that each of the assert statement is actually running in the background. Pretty straightforward, right? Like the names are very straightforward for you to understand them. The minute that you include Google Test, you should be able to run those assert processes. All right, let's look at a complete picture of my operator grader. I show you this, which is I'm testing operator grader specifically on the greater than. So I'm testing whether the first thing is greater than the second one, whether the first is greater than the second one. Now I'm gonna have a greater operator grader test case, but equal, meaning that when my medians are equal, it should return false, right? That's another test case that you can run. I'm passing in two things that are equal. One is a smaller number, one's a bigger number. They should assert to be false, right? And also I can do a less than, or a non-greater, right? So when the left is smaller than the right, this should also return false. Conditions, most common 3 ways of testing condition, right? No matter what the condition is, you're always gonna have some cases that's true, some cases that's false. When you're testing greater than or less than greater than or equal, you test whether it's actually greater, you test whether it's equal, and whether it's less than. That's all. That's all the 3 cases that you could have. So the philosophy of doing unit tests is that you cover all grounds. You cover as much as you could think of, even though you know that, oh, I am never gonna pass in something that's equal to here, you don't know how other people are gonna pass in it, right? Always expect other people will be using, calling, triggering your function, your class. So when you're testing for them for the most part, right? Not just for how you use it because you wrote it, you know exactly what you're going to input, not everyone else. Right? Alright, how about this, right? Your pre-increment and post-increment. Similarly, when I have a pre-increment, which is the operator I'm trying to test, I'm going to have that as my test case name. Inside that test case name, I can then test increase 1, increase 2. I can test increase 2 with, what's it called? You can test increase 2 with cascaded function as well, right? Because that's supposed to be a expected behavior for pre-increment, right? So when I mean increase 1 is the one on the top that you have seen, pretty straightforward. Increase 2, then make sure that you could do different type. When we're testing against numbers, the most important thing is what type of number can I accept? Integer, float, double, right? Sometimes people test long as well. I didn't test long here. This has integer, float, and double. And to see whether that operator can run for all of those different types. Now this is where I use equal, right? On the left is where I call this function, right? I call this function. That should give me M2, which is here's the height, I think, right? And then when you add 2, 1.2 should be equal to 3.2, and that should be of type float. Right? And so I will test that. Similarly here, assert equals on the left is your function call, on the right is expected output. You put assert equals, and it's your test case. How about post increment? Post increment is a little bit different, right? The post increment should return the pre-incremented version, and then when you trigger it again, it should then give you the incremented version. So I want to test both cases. For my post increment, I will test one thing is called current, which is what do I have currently. When you just do m1++ get height, it should not change the height. So that will be 0. So I think this is height. Now m2++ height 1.2 should stay 1.2 because this is post increment, right? So that should not change. So in here. However, for my post increment, post triggering, if you see here on my M1, I do it here, M1++, because that was tested. Right? I know that that works, that's all good, but I don't know whether once after I increase it, whether it should return the updated version of the height. So when I do M1 dot get height, that should give me 1. Similar down here, when I do M2 dot, that should give me 2.2. Right? Those are the most important behaviors for post. Let's see what it looks like when you run tests. When you run the test, you just have a very short main. I'm not going to go into all the details. That includes arguments that we haven't learned yet. But that will be your main. That would be how you initialize Google test. And that is what you return. Exactly the same thing if you pass it in. It will go into your file and look for all the test function. Remember, all the function called test. That's how you can find it. Everything's called test. You find all of those. It will run them, and it will format it in this way. This is Google test specifically, but it won't be too much different if you have other templates. Where you can see that, okay, it's running 7 tests, right? The 7 tests that we show from 3 test cases. The first one is testing operator greater than, right? And then saying that operator greater run, it runs okay. This is how fast it runs. Operator greater dot equal runs okay. Operator greater dot not greater run okay. Similarly down here, the second test case, pre-increment. Pre-increment increase 1, run okay. Pre-increment increase 2, run okay. Super straightforward, right? That's why unit test is so helpful. Now
One
let's
question,
change it.
if
Yeah.
I can. What's usually practice? Where we place these testing lines? Usually at the beginning of the code, end of the code, somewhere in the middle.
They're separate. Most of the time, they're completely separate
So
functions.
totally other file, right?
Yes, that's right.
Yeah.
You see, it has its own
Yeah,
name.
yeah.
Yeah, you can't put it together.
Yeah.
Yeah, completely separate.
Okay, thank you.
Now, what does it look like when it fails? Say that in my implementation of post increment, I decided not to return start this, which does not allow me to do cascaded function call. Then this will fail, and this is what it looks like when it fails. It will say, I am running post increment test current. I just ran that, right? First of all, it gives me the where that is, right? That's my test. It's going to say failure. Expected quality of those values should be 0, but I got 1. Fail. Operator post increment dot current. So we have a long list, super long list. Very easy for you to spot how you've been doing with this code changes, right? If you see all red, not so good. If you see all green, you have a couple red, you just go in and fix it, and your test should run back. So the good practice for a lot of programs is they write their unit test first. Remember when we are looking at our programming assignment, I give you expected output before you even write anything, right? You know exactly the expected behavior of each of your functions, each of your classes, each of things in your main, right? Your overloading operator, you know exactly how they should operate. You actually can write unit tests first. That's the best practice, obvious. Yeah.
How do you change the color of your output?
What?
to green versus red?
This is by default.
Oh, okay.
By default. Google Test just has it. So I didn't do anything. I just put that main in, I put the test in, that's all that is, there is. Right? Alright, the following, I'm gonna, don't worry about following the slides after this, because this is just for you if you want to try it. There's a lot of things in here that you have not learned yet, include like make file. So I'll just go over it and put it in the slide that once you go home and be like, I'm interested in trying this. Or 2 years later when you are preparing for an interview, be like, I want to try and run this, at least you have something to refer back to. Before you make anything, you need to have the CMake installed. This is where you go to install it, and then it's pretty nicely made now that you can just have a quick install before you have to do command line. After you install this, there's some configuration that you need to do so that you can find it can find your test. And there's a step for create a specific directory. So this answers your question where do all those tests go? You have your own directory that contains all the tests. It has its own main, it has its own code, and everything. It's all wrapped cleanly together in this GTEST folder. I think this leads nicely to our next one, which is version control. This is where you download Google Test. GitHub, it is probably the largest code base, including all the tech company will have their own space over there. They publish their open source program. People try to follow them because they always try to publish something that's good, and people just smash that and open source and become their own thing, right? Similar to VS Code when it's published by Microsoft, it's such a big thing. So yeah, so this is where you download it. It is inside the GitHub space we'll talk about. That under Google, and it's called Google Test. You can just download that. And you do need to make the CMake list file. That's all there is. It's only 12 lines. There's 8 lines, 7 lines with some space in there. You just write that in. That is how you configure your Google Test. You see the project name. I said the name of your project. But then you see how inline comment is super helpful, right? Without those, 2 days later, I would be like, well, what was this? You know. Inline comment is very helpful, so you know which line is what. You can modify those accordingly. And finally, this is the file structure of Google Test. This is the Google Test that you download, which is what supports the framework. You have your source. Source is where you put all your source code, right? This is my minion.h, this is my minion.cpp I want to test. This is gtest.cpp, which is everything that you're looking at. This is the file that I asked with 7 lines of code that you put in there. Then you can run it. After you either transfer or take more classes, all of those CMake files, all of those GitHub will make a lot more sense. And by the time you get back to it, all the files will be like, oh, I know exactly where to put it. Okay? If you're just going to try it now, the CMake expected output should look very messy, but it should look like this. When you have this, don't freak out. You're fine. This is how it should look like. Not that you break something. And when you do make, that is how you run. When you make, you can think of it's kind of a compiling, right? Make is telling your computer how to compile Google Test. And after that, when you just run this test, so I name it my tests. Very simple. I just run my tests and get my expected output, which is the screenshot I gave you in the previous slide. All right. I hope that's helpful information on unit test. I basically just wanted to give you this concept, right? Nothing to worry about like, oh my God, I need to run this. No. Having this concept in your mind that when you hear about this elsewhere, when you talk with other people and have this philosophy of I want to test my code, very helpful and very important. Next up, version control 101. I am not going to go into all the details of version control. Version control is as complicated as C++, probably overstatement, but very complicated. There's so many things that could go in there. I'm just, again, introduce this concept to you. Some of you probably already been using this version control. But then it is, for those of you who haven't started, it's good to kind of get started now. Why version control? Well, this is exactly why. Before you have version control, you will make copies. right? Because you don't want to lose any of your code. You write something, you run, it runs fine. 5 minutes later, you change something that you forgot where you changed, they're all gonna break, right? That's the most frustrating moment. You're like, oh my god, it ran before, what did I do? One way to solve it is just have a folder structure like this, where you have version 1, version 2, version 30, and then you have, okay, I'm done final, and then now you have final version 1, final version 2, right? And then you have like awesome final, and then you're gonna have submitted, awesome final with final changes, and then you have really final version 13.2, right? When you don't have version control and you're afraid of losing your code, this is great. We can't do this for every single program that we run or write, right? So what do? GitHub, the most popular and largest code base that I was showing you, right? Even the tech company go in there and publish their open source repository. It is free, and it is free with benefits for students even. When I graduated, I kind of lost some of my benefit from GitHub, unfortunately. But even though I lost, I think numbers of private report is what I lost, you can still use it, right? My page was way outdated because the minute that you join the industry, there's an enterprise version. You go in there, everything that you write belongs to them. It's not yours anymore, right? So you see, I have not made contribution at all after I finished my grad school because it is all enterprise protected. The interface for enterprise look exactly the same. So when you learn this, be like, oh my god, I'm going to use it for student. No, like the minute that you join, the same concept go, the enterprise version of GitHub looks exactly the same, very popular for industry as well. So what is GitHub, right? It is just a web page. It is, can think of it like a cloud server somewhere that GitHub owns, where they store all your code, but it's all in the cloud, right? It is different than what you have on your computer. We call that local. This is all in the cloud. Meaning that your computer crash, right? If you spill water on your laptop, you won't come to me and be like, Professor, I lost all my project and I'm 5 days late with no late penalty, right? That will not be the case anymore because everything is backed up on cloud. Now, why do people tend to create their profile and their image in their page here at GitHub? A couple things that people use GitHub for. They create their profile, right? So you could kind of see my old project that I was doing when I was in school, right? Either from grad school or undergrad school or others. My repository will have 9. And another thing is you can also see open source contribution, right? This is very important when you have 2 software engineers that come and apply for jobs. If someone have experience with open source contributing, great plus, a great plus. They have experience working with the group, they have experience doing code review, which I'm going to talk about. All of those are industry standard that students normally graduated without knowledge of, right? So when you start contributing to open source, you will learn of that by nature because that's the rule for how when you contribute to a big community-powered code base. You need to follow those rules. You can't just go in and submit your code and crash other people's code, right? Very important. People use that to show that. Another thing is just, people just click in. They click in and be like, oh yeah, how does Jen do documentation? Like, does she write clean code? Is her code completely unreadable? Right? Those are all flags. So people a lot of time clean up their repo when they're done, so that when people look at the repository, and we call those project repository, super nice and clean with nice documentation, all the lines are readable. It is kind of your profile. Think of your profile picture, right? So that your profile as a software engineer. That's why it's so popular, right? Because it's commonly used. First thing that you want to do, simply create your profile and then just create a new repository, as simple as that. Repository is the folder definition in cloud. You can think of that, right? Every single folder that you have been creating, I ask you to create a folder per project. Remember, I think starting project 2 or even starting project 1 asks you to do that. It's so that you have the idea of wrapping one project in one place and have another project at another place. So that you don't have a folder, have project 1, project 2, project 3, project 4. That's not the best practice. Most of people have folder contain project. Meaning that once you know that, oh, my project is containing this folder, that is the same thing as repository for GitHub, right? In GitHub, it's called repository. Short for repo, so you hear people talk about repo all the time. Short, it's basically repository in GitHub. Whenever you start putting your code or linking it to repository, every single line that you change, all the history will be kept. And you will see people accidentally put their username and password on there, and they'll be like, oh, never mind, just remove it. It does not work. So if you see a project and be like upload something, because people try to follow, it's like Instagram, right? We follow people's repo. I follow Google's repo, right? I know when they make changes, when they upgrade Microsoft, right? When they upgrade VS Code, I know about it. I follow them, and when they make a change, and sometimes when you follow this really popular repository of like 1,000 stars and something like that, and all of a sudden they delete their repository, they create a new one, and move all the follow over there, you knew that they submitted a password in there. There's no way you can remove that from the history except destroy the whole repository. It's very funny to see. It happens quite a lot. People just accidentally go, oops, my password's up there. It is because every single repository keeps all of the history. Deleting means nothing anymore. If you just go back to the history, you see that, oh, they deleted this. Copy and paste, that's your password, So no deleting the minute that removing the history. Also means that you will not lose anything along the history of you editing one code base. Some basic stuff on the repository. I'm sure you have a name of your repository. Most likely that will be your project name. We want it to be as readable as possible. Public and private. When you're a student, you get quite a lot of private repository for your own project because people know that students do project assignment that they don't want to share, right? They want to keep it private. They have quite a lot of private. The minute that you graduate, it's not gone. You don't have, I don't have 3, I think, right now, unless I pay. As I pay, I can get more private. But when you're a student, you should be able to do almost everything private. But right before people graduate, they will try to move things to public because they know they're going to lose that. And I'll talk about the rest, what's README and what's ignore and what's a license. We will kind of talk about that later. All right. The minute that you create an empty repository, this is what it looks like. It will initialize it with a git ignore, and it will also initialize it with a read. Okay, it doesn't show here, but when you click the git ignore, it's actually going to ask you to choose a setup, a language. What is git ignore? Git ignore is, you know how I tell you that, hey, you're going to upload everything you have in this project. You don't have to upload the cache, right? You don't have to upload the temp file. If you have a giant data file, you probably don't want to upload that. There's a way for you to ignore certain files in your local folder that you do not want to upload to the cloud. Meaning that you also lose the tracking. So if you go into your giant data folder and you change a column or change a row, you don't have that history kept, right? What you change is what you change. You won't be able to revert back. You do lose that, but there's something you just don't want to publish. You can put that in the git ignore. README is the documentation for every single repository. If you go into any repository and you scroll down, on the first page is what the README file is populated. It's kind of like a simple, we call it markdown file. It will just have simple formatting for you to write a document. That's all. Alright, so now that you have created an empty repository on GitHub, right? How are you going to contribute code? There are 2 things. The one that I was looking at GTESTS, Google Test, I asked you to download. We actually call it cloning. Download means that you make a copy of the cloud to your own machine. Cloning meaning that you make a copy, but they are linked. Okay? So if you imagine on the top, here's the cloud. Great. On top here, on the cloud, right? And here's your computer. The one that we just created, the repository, this one here, right? Same. In here we have, what do we have? dot ignore dot get ignore and remove. Alright, it's empty. Only has 2 files. It's empty. Now, the minute that you clone, means that I'm gonna make exactly the same one down here. Okay, it's your local machine. It's gonna have the same copy, get ignore, and read. Okay? When you clone though, they are linked. When you download, they have no relationship whatsoever. Okay. What does linking means? Meaning that you will have this notion of local versus remote. We call this remote in GitHub. We call this local. I mean, yeah, local is pretty standard, but we call whatever on the cloud remote, and this is on your local machine. Now, there are certain things that you could do after you clone. Most of you have a default setting on your computer to kind of hide. What do you call it? Do not show hidden file, right? Most of it should. And the way that Windows identifies hidden file or Mac is that if they start with a dot, that's hidden file. So you see when I first downloaded it, I only have 1 file, but just because this is hidden, you do have both files in there. The software that I use is GitHub Desktop. Is very nice user interface when you're not familiar with command line arguments. Once you get more used to interacting with the terminal, people just tend to get rid of it and just use either their VS Code, IDE, or to use command line to interact with it, which is fine. Before you're familiar with that, you can also have this nice UI to help you interact with GitHub. And then this is the interface. You have your repository name. We talk about branching, and this is the link. So this is a fetch. Fetch meaning that get it from here. And then once you fetch, and if you change something here, you have an action called push. That's why it's linked. You can make connection between the two. That's where you do it. And then here is the commit, which I will talk about as well. All right, let's make some changes. This is now in my local machine. Looks like a folder. Nothing different than a folder, except if you show hidden files. If you show hidden files in your folder, you will see in there, there's a .git folder. Oops, here. .git folder in your local machine. That is the one that's distinguished regular folder. So say you have another folder. You have your project 1, .c++, right? You have like other folders in here. If this folder does not have the hidden .git, this is a regular folder. For a folder that with the hidden .git, that is linked to GitHub folder. Okay? So when you just look at it, you really can't tell the difference. But if you show our hidden file, then yeah, you will be able to see it. All right. That's versus local versus control. All right, let's make changes. I am gonna in my local add my GTEST, right? I have the GTEST.c++, I have the cmakelist.txt. I'm gonna add it in here. I'm just gonna write a cmake GTEST. Okay, when you have that, okay, when you change your, this is your local machine, when you change things in your local folder, it is on your at your machine, right? You change that, sure. Now, when you go to GitHub, github.com. When you go to GitHub, which is the cloud, you see this. I mean, you don't see that. You don't see the docket. This is the local folder. You see that. Okay? Which is different than this. Because only have changed it locally. Now, after you change it locally, how do I make sure my cloud is in sync? It's called commit. Commit is where you have changed many files in your local system, and you want to package all those changes together into one push up, push. That is called one commit. Each commit has its own name. Okay, so before we go there, the way you go into the software, you will see the changes that you just add. It will indicate that you added 2 files. You see there's not checklist because it doesn't know which one you want to commit. You can not commit one of them. You can just commit 2 of them. You can commit that one, you can commit that one. It's up to you. So if you want to package them all up into one commit and push, then you just check those checkboxes, right? So check those. Put in how you're going to name your commit. My commit is called I added a CMake and GTEST files. And then I click commit. The minute that you click commit, it's not up there yet. Commit means package. I'm going to package up those 2 into a commit now. So those are bounded, and that commit is shown here. It's down here. They're still local until you see that that changed to push, because there's something for you to push now. You can push that. Now that is where this will go up to here, and then once you push, you will have what's on the right, right? The files that you would just push will be here. Now how do I know whether they're from the same commit? You see the name here. The initial commit is auto-generated when you create a repository, and now once you commit, you'll be like, oh, those 2 were committed together. Now, when you want to look at history commits, you will be able to see that now there's 2 commits total. You click that, you can see all the commits. So that's all where all your histories are. Now instead of adding, let's change something. The UI is pretty friendly on looking at what changed and what not. If I remove some lines, add some lines, it's going to very clearly indicate that you minus those 3 lines, plus those 3 lines, green and red, very nicely indicated. And it will tell you which file that you had. So instead of the green add mark, it will be like the yellow dot. That means you changed it. Once you do that, then you can again do a commit. Yeah, do a commit, and then once you go to remote, you will see there are 3 commits now. File structure will not be changed because you just changed one file, the contents of the file. But you see the commits are again. Now this is when I go to the commits, you see all my commits here. Yeah? Alright, well how about local? Yes, in local, you can see all your commit history as well. Go to the history tab, and then you can see all your commits made. Now that you have a fully tracked history, that you decide where the checkpoints are, so you can think of checkpoint 1, checkpoint 2, checkpoint 3, right? You will commit when you're ready. Most of the people commit when it's compiled, right? It compiled, or they finish writing a module, they finish writing a class, they start committing. Can I revert, right? Oh, I did a commit and oops, that broke my code. Since I have all my history, yes, you can just right click on one of them commit and you can revert. And then you'll be like, wait, but you said I cannot revert. Yes, you do not lose the history of revert because revert is basically another commit that removes your old code. So inside your history, you have 4 commits now. One of them is called revert this commit. You never lost any. You do not lose anything in this history of changing the repo. Okay? You added a password? Sure, you can revert it. I click in there, I see your password. Okay? So if you don't want to keep something in your file history, then make sure you put that into ignore. Otherwise, everything will be tracked. But yes, it's very convenient to revert a commit. You can even revert a couple. So if I say I have 1, 2, 3, and I don't like any of those, you can right click this, revert, it will revert all the steps. up to here and give you this version. And you can start writing from that. Very convenient. Alright, now let's talk about README. README is the documentation. It is a language called Markdown. When I say language, it's like just a very simple formatting. If you want to read more about README, just go to that link. If you want to read more about Markdown, just go to that link. And that is what you use to write simple documentation for your code. You see, here is my README. I added that line, I added that line. This is what makes this a title, bolded and big. I added that in, I commit that. Now that's populated on the main page of this repository, meaning that the minute people click into this repository, they see documentation right away. So they know what this repository is, what it does. Imagine that Google just published Google Test. You're like, what is this? Right? You click in, super detailed documentation updated. Alright? I'm just going to cover all of that. There are so many things on version control. But for now, since you're not only working with yourself, don't need to worry about branching, you don't need to worry about pull requests. But at least I want you to know about repository and version control. And start building your own profile. Please do not upload your solution to a public folder or public repository. If you do want to version control your project assignment, make it private. Alright? And yeah, now that you can see where the Google test is, and you can go and find all the plugins that people write, you can see all the repository that's out there. For all the news that talk about large language models, right? All the news that talk about DALL-E 2, Midjourney, that's image generation, stable diffusion, all there goes around GitHub. All of those, right? As long as it's open source, you can find it. It'll be huge, but you can find it. This is where you find all of the open source repository and open source code base. So yeah, that's all I want to cover today.